Hey guys, welcome to my second video on UHS and MDCAT chemistry. Once more, we will be doing questions dedicated to familiarize A-level students with the different coursework of FEC, on which the end test will be based, and to give them a bit of an idea of how to proceed with their preparation. When acetic acid is treated with thionyl chloride, then ethanoyl chloride is formed along with side products. So what is the mechanism? So acetic acid is basically ethanoic acid, and we're treating it with thionyl chloride, and thionyl chloride is basically a reagent that is used for chlorination, and this is something you are actually familiar with. And what happens is that in addition to ethanoyl chloride, SO2 is also produced, as well as HCl. And what sort of a reaction is this? Because it's just the replacement of an OH with a Cl, that is one nucleophile for another. This is termed as a nucleophilic substitution. Question number 2. Mark the incorrect statement. Aliphatic acids are also called fatty acids. Yes, but not always, because this is only for monocarboxylic aliphatic acids. The lower members are soluble in water. Yes. And acetic acid is synthesized on commercial scale from ethanol. Well, it's certainly a possibility. And a polypeptide has a molar mass up to 10,000 AMU. This is true. This is also true. This is also true. And this is all only partially true, so we'll mark this. And if you have the book with you, the carboxylic acid topic is the last one, is one of the last ones in Punjab textbook part 2 from page 250. And if you look at the manufacture part of it, they will have mentioned the commercial and lab means of production and other stuff, and it's important in my opinion. Right, so there are a number of methods of preparation, and they've indeed written that primary alcohols and aldehydes can be readily oxidized to corresponding carboxylic acids by oxidizing agents like potassium dichromate in acidic medium, and that aldehydes are so easily oxidized that even mild oxidizing agents like toluenes can be used. Unfortunately, they have not mentioned whether this is a commercially feasible process, but it's certainly possible, so we will go with it being commercially feasible. And this one is definitely true. And if it's less than 10,000 AMU, it's more than 10,000 AMU, it will be considered a full-fledged protein. So which of the following alpha amino acid is not optically active? And the answer is glycine. That is the only one that is inactive in all of the 20 common amino acids, because it has 2 H's and so lacks a chiral carbon, any chiral carbon. So dash is added as a flavor in Tetra Pak orange juice. Now this needs to be an ester, and they've given just the examples of esters, and there is this table in the book in the carboxylic acid topic, and over there if you will look, it will be written that the ester octyl acetate, it has a certain particular flavor like that from orange. So the answer is B, and this is pure memorization. It's on page 257 for those of you who want to check the other ones. Which of the following carboxylic acid substituted carboxylic acid has greater acidic strength? Well, if you compare these, this one is definitely more because of the electronegative fluorine making this more acidic. And then over here, if you compare, the answer is definitely a B because the more F, the more electronegativity, the more the electrons are taken and delocalized. So what is the name of the above given structural formula? Well, if you observe, you'll have to look at how many functional groups we have. We have 2 carboxylic acid groups and we have 1 amine, and these have clear priority. So 1, 2, 3, 4, 5. 5 is pentan, and because we have 2 of these, it's 1,4 pentan tartaric acid, and because we have to include this, it becomes 2 amino pentan 1,5 tartaric acid. But over here they've only given the options in terms of their commonly used name. So let's see, is it adipic acid? No. Adipic acid is indeed a dicarboxylic acid. It has 6 carbons in total and it does not have the NH2 portion. So a resounding no. And in the case of aspartic acid, this one is extra. We just have a CH2 with a C double bond O OH attachment. This is wrong. Aspargine is not acidic, so it just has one of this, so it doesn't have this at all, and you don't even have to consider it. Glutamic acid, on the other hand, is the correct one because it has CH2 CH2 C double bond O OH attachment, and this has been drawn in a table in the amino acids topic, which is actually part of the carboxylic acid derivative chapter. So I would suggest you really take the amino acid topic really carefully. So which of the following carboxylic acids is produced by the acidic hydrolysis of methyl nitrile? And these are a bit tricky. If this was there are different ways of saying this because nitrile suggests the presence of this. So if this was methyl cyanide, it would actually have been like this if it was methyl cyanide, because cyanide already includes a carbon portion, but because it's methyl nitrile, that means that the nitrile part does not include the CN, so we only have 1 carbon, so this is the right one. And so when we start with this, we start with a methyl nitrile and we undergo acidic hydrolysis. What are we going to get? We're going to get methanoic acid, obviously, because it has 1 carbon. Propanoic has 3, ethanoic has 2, butanoic has 4. So which of the following reagents is used to form ester by the reaction with carboxylic acid? NaOH, obviously not. PCl5, no. Alcohol, yes. So this was a really obvious question. This sort you get free marks out of. So which of the following carboxylic acid has the smallest pKa value? Smallest pKa means highest Ka value, and the higher the Ka value, the more acidic something is. fluoroethanoic acid, chloroethanoic acid, bromoethanoic acid, or iodine. It should be A because fluoro is the most electronegative, A is likely to have the greatest electron withdrawing effect and is so likely to weaken the OH bond the most. So peptides are compounds formed by the condensation of two or more same or different alpha amino acids. They can be the same, they can be different, they need to be at least two, but can most certainly be more than two. When glycine and alanine are condensed, then glycyl alanine is formed, and the resulting peptide linkage is called a dipeptide, a tripeptide, a polypeptide, a tetrapeptide. It's called a dipeptide because even though we're talking about linkage and we just have one of them, when we say something in terms of peptide, we're actually referring to the amino acid residues. So this isn't strictly part of the syllabus because amino acid naming isn't, but let's do this anyways. 2-amino, meaning it's on the second carbon, not the alpha. 3-methyl butanoic acid. Butanoic acid would mean there are at least 4 such carbons. 3-methyl, 2-amino. So this one needs to be 3-methyl. So this is obviously valine. Because of this attachment right over here, isopropyl attachment. So what is the name of the amino acid? Where are its H group? This is obviously glycine, the simplest amino acid. 20 alpha amino acids are required for the synthesis of proteins. These alpha amino acids are subclassified according to how the properties of other functional group in the side chain influence the system. Which of the following is not justified class of alpha amino acid under the given condition? It's non-polar if the side chain is an alkyl group. Makes sense because alkyl isn't polar. Acidic if the side chain is HCl. We don't have that sort of stuff. HCl cannot possibly be the side chain. It's polar if the side chain is amide or alcohol. Somewhat possible in case of the alcohol, not so, and maybe even in the case of the amide. It's basic if the side chain is an amine, definitely. Also to an extent correct. Now you should know that there are 2 amino acids that have OH portion to it. One is threonine and the second one is serine. These are important stuff you need to memorize. Just as you need to remember that glycine tastes sweet and that glycine is also non-optical. The amino acid which contains both a primary and a secondary amino group. Now proline just has a secondary, sadly. A lysine just has a primary, in fact 2 primary. Alanine just has 1, so we're left with just histidine. And histidine indeed has a secondary amino acid because in total there are 3 amino acids out of 20 which possess a secondary. One is proline, the other is histidine, and the third one is tryptophan. Now you need to be aware of the structure of histidine because it's given in the book. It's pretty difficult, so you don't really have to memorize all of it, just to have a basic idea. So obviously this is the generic part. We have an H attachment, we have a carboxylic acid attachment, we have an NH2 attachment, In addition to that, we have the CH2. We have another C. And then we have a double bond. And the C is connected to this N via a single bond. So it still has this one valency, so we have an H part over here. And this N is double bonded to a C, so its valency is fulfilled. And the C is, and this also has an N, but it also has an H, because there's a single bond over here. So it needs this H to complete its valency, and we have an H over here. So from this it's obvious. Here is the primary, and here's the secondary amine portion, and this is tertiary. Might not even be considered as such tertiary because of the double bond. So we don't consider this, it's just an atom that's just doing whatever. We're not so sure about tryptophan because in the book it isn't given. But it's not really in question because it's not given as such. So the name of the following amino acid is, so we have a CH, we have an NH2, and we have a CH3. So this is basically the R group, and this is obviously alanine, and it's one of the simpler amino acids, perhaps the second most simple. Now alanine along with glycine is surprisingly one of the non-essential amino acids, that is the one the body is capable of producing on its own if given the raw material. Alanine is also one of the non-polar ones, and there's 5 such non-polar amino acids out of 20, so it's pretty simple. It's not simple, it's pretty special. Now the thing with histidine is that it's basic. It's one of the basic ones. It's also acyclic. It's also cyclic, and a couple of other stuff. And the nature of lysine amino acid, it's basic, and if someone asks for its formula, it has NH2, it has a COH, so it has a normal primary amine. In addition to that, it has a chain consisting of 4 carbons. We'll represent it like this, and to the 4th one we have this NH2 attachment. So it has 2 primary amines. So what is incorrect about valine? It must be supplied to your body through the diet. That is not incorrect, it is one of the essential ones. Its deficiency in our diet may not cause disease. This is absolutely incorrect. It is basic. It does not show optical isomerism. Now that is questionable. I do believe it shows optical isomerism. So this is a bit iffy. It's definitely basic. It's definitely essential. So it must be supplied to our body through the diet. Its deficiency in our diet may not cause disease. This is definitely wrong, but this is also kind of questionable. I think there is this over here. There is this misprint. So ethanoic acid reacts with all of the following to produce water except ethanol. No, with ethanol it would have acidification with the formation of one ester bond accompanied with the evolution of a molecule. With sodium we would have H2 and not H2, and this is probably an answer, but let's look over here. With caustic soda we have neutralization, so one H2 per molecule neutralization. Same with sodium hydrogen carbonate, we have CO2 and H2O. The relative acid strength of carboxylic acid, water, ethanol and phenol has the following order of increasing acid strength. So this is the most strong, and then we have surprisingly we have phenol, and then phenol is stronger than water, and ethanol is the least strong. We know this from A levels, so I don't think there's any class need for any sort of elaboration. So all of them are alpha amino acids, except adipic acid isn't even an amino acid. It's a 6-carbon dicarboxylic acid. In the formation of zwitterine, which one of the following donates the proton? The proton is donated by this, is received by this part. This is strange because you are making this a part of it when it isn't necessarily. This might be true in the case of glycine, but not the rest of them. OH never does that. Even if it is present, it makes it polar but not acidic. So which of the following alpha amino acids contains element of 6 group other than oxygen? So if you're familiar with the 6th group, it's oxygen is in, I believe it's in group number 2. So oxygen, sulfur, selenium and tellurium. You'd probably have never heard of selenium or tellurium being part of an amino acid, but sulfur certainly is. 2 of them. One is methionine, the other one is cysteine. So do we have one of that? Yep, cysteine is right over here. Next, all are dicarboxylic acids except oxalic. Definitely, it's 2-carbon malonic, 3-carbon. Now, tartaric acid is also a dicarboxylic acid, and its formula is, it's actually given in the alcohols topic, surprisingly, because it's like this. So it has this formula. It's a dicarboxylic acid and also has dihydroxy portion. And this is how it is. So even if it has the 2-hydroxy, doesn't change the fact that its priority group is a carboxylic acid and that we have 2 of them. So the answer is citric acid, which we don't even know about, so it's the only option left. So acidic amino acids include asparagine, glutamate, no. Aspartate, asparagine, no. No, actually this is it. This is alright, not this part. This is right. Because this is the salt form of it. Glutamic acid and aspartic acid are in this form. You might be confused with asparagine and glutamine, but asparagine and glutamine are entirely different amino acids and they are not acidic, even though they are indeed polar. So you need to realize that glutamine, asparagine, glutamic acid and aspartic acid are different, but aspartate and aspartic acid and glutamate and glutamic acid are the same. So alpha amino acids are said to be amphoteric in nature, and the acidic character is due to NH3 plus and CO minus. No. NH3 plus, sort of. Yes. Or this one. Is it necessarily because of these? Well, the presence of 2 COOH will indeed make it to be overall acidic, but not in this format. Because after it has lost the H, it has become a conjugate base. It's no longer acid, even though initially it was. And even though initially it was a base after having gained the H, it has become a acid, even if it's not an altogether strong one. So an incorrect statement about alpha amino acids is the deuterine is called an eternal salt. Yes, it's in the introduction. All alpha amino acids exist largely in dipolar ionic forms. They do. The NH2 group always present on alpha carbon in all naturally occurring amino acids. Well, not all of them, just the majority of them. This has also been written in the book. No, I'd be wrong. All of them are alpha. Beta amino acids are definitely not naturally occurring. All of the naturally occurring amino acids are alpha. My apologies for having initially misled you. The answer is D. Because all of the ones in nature are alpha. And let's just take a look at the amino acids topic just to be sure. It should be in the introduction. Right. The amino acid may be present at any carbon atom other than that of the carboxyl. They are referred to as alpha, beta and gamma depending upon where the amino group is present relative to the carboxyl, and almost all of the naturally occurring amino acids are alpha amino acids. And these amino acids are very important because they are the building blocks of protein, and proteins are very essential. Now this is a bit of a difficult. They've said that almost all of them. So it's a bit, this is a bit of an ambiguous question because they're saying that almost all of them but not all of them, but I would still go with D being incorrect. So perhaps this should be subject to some research. So all of the following are types of amino acid on the basis of the nature of the R group except amphoteric side chain. There is no such thing. Polar side chain, yes, in the case of plenty of them. One, two, we have actually five, or maybe it's even more than that. Yes. There are 5 amino acids which have a polar side chain, and we classify them as such. 3 that have a basic side chain, 2 with an acidic. There isn't an amphoteric side chain, even though the molecule itself is oftentimes considered amphoteric if the number of NH2 and the number of C double bond OH are the same. So which one of the following is the weakest? Trichloroethanoic acid, chloroethanoic acid, dichloroethanoic acid, or simply ethanoic, because this has no electron withdrawing influence. So which one of the following alpha amino acid contains a polar R group? Alanine, no, it just has CH3. Valine, no, just isopropyl attachment. Aspartic acid, on the other hand, it's acidic because it has this. Proline, on the other hand, is, I would think it's one of those that are neither acidic, nor is it basic, nor is it considered polar. So that is one of the few that is non-polar. Yep. So proline is one of those amino acids whose structure you should be familiar with. So what's it like? So we have the normal. Alright, it will be easier to show like this. Like this. Because this is the way it's been drawn in the book. And it's less time consuming. So we have the NH portion over here, except it's a bit different than what we're used to. And over here we have a C attachment that is kind of like this. It's attached to another C like this, and this is attached to an N group, to a C group, which is like this. Which also has an attachment like this. And normally we would have an NH portion, except it's like this. And so we just have one H. So this is effectively this part all over here is effectively the side chain, and it's most certainly non-polar. So which one of the following is the structural formula of glycine? Glycine has an H for an R group. This one is it. This one is alanine. And over here this one is glutamic acid. And this one is aspartic acid. So which of the following derivatives of carboxylic acid is not prepared directly? Acid halide is fairly easy, you just need to use PCl5. Acid anhydride, it's fairly made easily. You need P2O5. It's just the catalyst that you need, and the reaction ought to take place fairly easily. Esters happens. We just need H2SO4, whatever acid amide. Well, for that to work, you have to first convert the carboxylic acid into an acyl chloride, and then you're going to have to react with NH3. So answer is C, something we A-level students know. Alpha amino acids are compounds having carboxylic acid as well as amino functional groups attached to. Any H atom in the molecule, obviously wrong. To the same carbon atom, yes. That is what makes it alpha. So the carbon that is next, right, adjacent to the C double bond OH is alpha. The one that is one carbon away is beta. And then it's Charlie and so on. You need to remember how this works. Ethanol can be converted to ethanoic acid by all of the following except this is an aldehyde. Considered HNO3 should work just fine. It's a good oxidizing agent. Should work very well. Except this doesn't usually exist, and is most likely not an oxidizing agent. In this case, dilute HNO3 would have worked as well, probably. Interesting thing about concentrated HNO3, a bit of a tidbit, is that its third strongest HCl is strongest, followed by H2SO4, and I believe after that you will get to HNO3, and this is actually part of, it has been mentioned in the equilibrium topic, page 214. There is a table. I would recommend that you get an idea of the order of acidity. And yep, my apologies, it's actually HCl followed by HNO3 followed by H2SO4. That is the order that they follow. So it's the second strongest. So the complete oxidation of ethanol produces first ethanol, then ethanoic acid. So you need to mark the incorrect statement about alpha amino acids. The alpha carbon is present in all the alpha amino acids except glycine. That is wrong. It's present there as well. All naturally occurring alpha amino acids are L. Possibly correct. Vitamins contain only L amino acids. The valine alpha amino acid has a polar side chain. Valine most certainly does not have that. Think about it, if we drop the structure, they're saying that the alpha carbon is present in all the amino acids except glycine. I do think it's present over there as well, because this is the alpha and it's over there. So this is most certainly wrong. We talk about valine. Valine has a polar side chain, it doesn't. Again, this is a controversial one. We will revisit this. Amino acids are building blocks of proteins. Which the following exist as cyclotimer in aqueous solvent? And the answer is the only carboxylic acid, because they do that. The amino acid which is synthesized by the human body are called non-essential amino acids, and esters are used as artificial flavors. What about ethyl butyrate? And again, it's simple memorization. The answer is pineapple, and you need to really memorize this table. It's pretty important. This is it for this video. If you like, please like and subscribe and leave comments in the comment section.